All right, good morning, guys. We're going to review again today for our exponential functions, exponential equations quiz that we're going to have tomorrow on Friday, April 3rd, 2020. So we're going to start looking at exponential equations just from their definition. I think it's a great place to start. So again, an exponential function. Exponential function is a function with the variable x in the exponent. So, if it's exponential, we should have an exponent, but not just any exponent. We've got to have x in the exponent. And I could have, y equals 9 to the x minus 1 plus 2. I could have something like that where I have x and something else in the exponent. That's all right, as long as x is in the exponent. That's really what I'm concerned about. So let's take a look at these first three, and then I'll leave the next three for you guys to do. So what we're looking for again is we want to know, is that variable x in the exponent? So here I've got an exponent, but what is in that exponent in number 1? Well, it's the number 3. So I don't have x in that exponent where I would like it to be. So I'm going to have to say that this function, and it is still a function, but it's not an exponential function because x is not in the exponent. All right, what about number 2? I've got a lot of stuff going on here. I've got 5 times 11. I've got an exponent. We've got y equals. But what we're really concerned about, I'm not even really worried about this 5. It doesn't matter what the number is here. What's important is that in my exponent, I have an x. And since I have an x in that exponent, since that variable x is in the exponent, then I would say that this is an exponential function. So why don't you guys pause the video, try these next, try the next 4, see how it goes, and then you can unpause the video, and we'll go through these together. All right, welcome back. So number 3, again, we're looking for x's in our exponent. So here I have an x, but what operation am I doing with these two terms when I've got them just kind of pushed up next to each other? Well, this means 3 times x. So since I'm multiplying, since I don't have an exponent, then I would say that this is not exponential. Again, because I don't have that x up here as an exponent. And number 4, I do have an exponent. So that exponent is there, but unfortunately, the exponent is not my variable. X is not up here in the exponent. And since x is not there in the exponent, I'll say that's not exponential. Number 5 looks a lot like this one here in the upper right corner of your screen, where I've got a number, an x plus 3 in the exponent. We've got to ask ourselves, is that okay? Can I have something else in the exponent? Well, let's look back at our definition. What are we concerned about? Our big key focus is that the variable x is in that exponent. I'm not worried about anything else. I just want to know, is x in the exponent? And since it is, even though there's something else here, it could be x plus 3, it could be x minus 1, like we saw in the upper right corner. It could be whatever you want, as long as x is in that exponent, then I'll have an exponential function. And this last one, we haven't even gotten close to this yet. So if you're not sure, if you've never seen that function before, I would always guess not exponential. If I saw something I'd never seen before, that would be my guess on a quiz or a test. And we're going to fill out these tables below. I'm only going to fill out number 7 for the sake of time on this video, and I'll leave you guys to do number 8. I'll post these completed notes later today on Classroom, so you can always check there. But what we're going to look at here is 6 to the x for my first function. This is an exponential function because I have x in the exponent, and we're going to substitute in these x values in for x. So we'll say 6 to the negative second power, or 6 over 1 to the negative second. So what do we do with a negative exponent? Well, anytime I've got a negative exponent, I've got to move that down into the other part of the fraction. So 6 to the negative second turns out to be 1 over 6 to the second, or 1 over 36. And you're going to see the same thing here when you're doing the next table. Same idea, 6 to the negative first over 1. And we've got to move that negative exponent. So 6 to the negative first needs to move down to get rid of the negative exponent, which is just 1 over 6 to the first, or 1 over 6. This is 6 to the 0, which is just 1. 6 to the first is 6. 6 squared is 6 times 6 is 36. And 6 cubed, or 6 to the third, is 216. So I'm going to erase this just to clean it up, and I'm going to highlight this is really all I need. These are the numbers I should be focusing on. So this is what I would really fill in to my y column if I was trying to make it as clean as possible. And I'll leave you guys to finish number 8. Now, 9 through 12, again, we're looking for, let's change colors here. We're looking for exponential functions. So we're trying to determine, are these exponential or are these linear functions based on their tables? So looking at the table, again, I'm only going to focus on this y column. This is my only concern for today, this y column. And then be careful, down here, this is the y column. And here's the y column. So I'm only looking at that y column, and I'm going to ask myself, from top to bottom, how is this changing? So from -2 to 0, what's happening? Well, I could think about, maybe it's multiplication. I would like to see an exponential function. So maybe I'm multiplying by 0. But then would that pattern hold? Would 0 times 0 be 2? And of course that wouldn't work. So I've got to think about a different pattern. How else could I go from -2 to 0? Well, I could add 2. And if I add 2, does that pattern hold? It seems to. Let's try the very last one. And yeah, that seems to hold. So my pattern here is I'm adding 2 every time. And if I'm going up by the same rate every time, if I'm adding the same number, then if I were to graph that, 1, -2, 2, 0, something like this, going up by the same rate every time, a constant rate, would look like that. That would be a linear function. So anytime I'm adding the same thing, that would be linear. And let's look at number 10. So from 17 to 51. Well, I do want an exponential function, so why don't I check for that one first? So I can see, what is 51 divided by 17? Do I get a nice whole number? And I would end up getting 3. So what that tells me is if I multiply 17 times 3, I would get 51. And let's try with our calculators. If I do 51 times 3, do I get 153? And if I type that into my calculator, then I'll see that works. And we'll check the very last one. 153, if I multiply that by 3, then I would get 459. So this one looks like the pattern is multiply by 3 every time. And if I'm multiplying by the same number, then this would be an exponential function. And we can kind of see, if we compare this to this table that I did over here, what am I doing every single time? From here, I'm multiplying by 6, so 1 times 6 is 6. And 6 times 6 is 36, times 6 is 216. So that's why multiplying by the same thing every time means an exponential function. And I'd like you guys to try the last two, so just pause the video and then we'll check here in a second. So in number 11, I'm multiplying by 2. So 6 times 2 is 12, times 2 is 24, times 2 is 48. So if I'm multiplying by the same thing, that's exponential. And here, again, we're looking at our y column, minus 9, minus 9, minus 9, minus 9. So if I'm subtracting the same thing or adding the same thing, that would be a linear function. All right, and we've got just one more topic to cover before we are done for the day. So we're going to classify these following functions as exponential growth, exponential decay, or neither. And let's look at this first one. So it's starting off very, very small, and then it gets really, really big. And if we look at this exponential function in number 11, if I kept going back, I multiplied by 2 to go in this direction. So the number before 6 would have to be 3. The number before 3 would be 1.5, and 0.75, and 0.375. So you can see that here it's growing very, very slowly. These are really small numbers. And then these numbers would start to get pretty big down here. So exponential growth is going to look like this, where I've got very, very small numbers in the beginning, and then it just explodes upward. Gets very, very big. So again, this one kind of looks like a playground slide or a water slide. Maybe I'm up here. Give myself, I don't know, like a balloon maybe. Maybe it'd be orange. Hanging out at the park. Gonna go down this slide. It'd be kind of a scary slide, but it's a slide nonetheless. Number 14, so this one is exponential growth because from left to right it gets bigger. Number 14 is just a line, so I'll call that it's neither exponential growth nor exponential decay. That's just a linear function. And these last two are both exponential because they look like, those playground slides. But we've got to know if they're exponential growth or decay. So from left to right, what are they doing? So from left to right, what is this one doing? Well, this one from left to right is going down. So if it's going down, that must be exponential decay. And 16 left to right is going up, which must make that exponential growth. All right, so on the Google Classroom page, keep an eye out for that Google form. That's your homework and your attendance for the day, of course. So, as always,